For me, my part, so how to build a data center. This sounds like a very sort of high-level statement. Why would you care about this? The reason you should care is cloud's going to win. How should you build a data center if cloud has already won? So my name is Nils Swart. I run product management at Skyport, and I started sort of at the other side of the table. In this case, I used to work at companies that acquire technology and use that for a living, and moved over to the dark side. Decided that building products is great, changing them is even better. So now I'm stuck in this middle between customers on one end and engineering on the other end. My clicker decides not to work at all. That's kind of annoying. It should just work. Yes, it works again. Whew, save the day. First off, what is Skyport? Without burying the lead, we decided let's throw some slides together first on what is Skyport. So Skyport is a cloud-managed on-premises virtualization platform. It's a lot of words, but what it really means is we have a hyper-converged platform. Indeed, a piece of hardware that you've seen here that goes to our customers and runs inside their data centers, and it runs inside their remote branches, colo facilities, wherever they need compute, wherever it needs to be close to end customers. The thing that's different, there are a bunch of things that are different, but one of the things that's different is this is entirely cloud managed. You don't manage these things locally, you don't directly go to a management service on the device itself, but instead it connects out to the cloud management infrastructure, and you administer that entire system and all of the resources with it and all the VMs that run on it from one central place. So you dot them around the world. You have 10 locations around the planet or around the United States. They're all managed through the cloud management service. It's software updated that way. Logging, monitoring, et cetera, is all done through the cloud management interface. That still sounds kind of vague. What is it that's really behind this? We've taken 5 large chunks of technology that you typically had to integrate yourself, and that we've had to integrate in our past lives, and we've pre-integrated them from the perspective of security first. So that's virtualization, storage, security, networking, microsegmentation that goes with it, as well as analytics. And we've realized that integrating these is actually a really, really hard task to do. But it pays off. It pays off because as soon as this was delivered, basically we could turn around to customers and say, we've built this for you. We run it for you for the most part. We've secured it for you. We have hired a lot of paranoid people in our organization, and then we support it as a cloud service as well. So that's all good. We'll go through all of these details in the architecture session, but where would you see Skyport today? Our customers could roughly look like this, where there's a large chunk of bulk compute sitting in the center somewhere, a number of data centers. There's a growing set of services that they're using outside on the cloud. Whether or not it's actual SaaS services or infrastructure as a service, that's all. It's all good. Where they specifically use us is in 3 categories. Number 1 category, critical systems. They've realized that not every workload is created equal, and my colleague Dan will go into a lot more detail on that. Not every workload is created equal. You pretty much have to deal with certain workloads in a specific way. Lift them out of your software-defined data center and out of that pool of compute and run them in a place where you can both observe it better but also control it better. Then there's a separate section of use cases for our customers that deal with all those workloads, all those virtual appliances that vendors ask you to install somewhere. Like, just install the virtual appliance somewhere here in your data center and just give it access to anything because that's kind of what you want, right? Now these workloads are kind of special. They connect outwards. They create a network connection. You kind of want to monitor those. You kind of want to control those. And rather than running that in a big, large bulk compute, run them in what essentially looks like a next-generation DMZ. And we'll talk more about that clearly too. And the third one and last category here, remote branches or anything that's distant from your headquarters has similar requirements to what a data center has. But it's been very hard to get to that same level of control, same level of security for that. From our perspective, and our customers are using us in branch locations. They drop ship it into various countries, and we'll talk specifically about how the drop shipping nature and validation, integrity measurement, attestation, et cetera, come into play. But long story short, there is bulk compute, and these use cases around it are the ones where we cherry pick workloads out and allow customers to grow their installed base in that front. So with that out of the way, onwards to my real section. And that is, and again, it sounds pedantic, but how to build a data center, specifically in the case where cloud wins. Because we firmly believe that cloud wins. And specifically, it wins, and it's happening right now. There are a couple of things that are happening right now. First off, cloud wins and it's going to eat your data centers. And that may be a controversial statement to make, but we strongly believe that's the case. We talk to our customers, we see it happen all the time. It eats your existing data centers, but it doesn't mean that your data centers go away completely. There will be data centers that will remain, but the operational model itself will be entirely different from what it is today. So it doesn't look like what you would have in data centers today. The other part of this is bulk compute, homogeneous compute, has no reason to stay behind. It's homogeneous, it's going to move, and for a number of other reasons as well, this is just happening as is, and it will move upwards. There are a few exceptions to that. We'll touch on those too, but some stuff should just not move. We see customers move that too, but we'll see that return. Things that have high value intellectual property in the form of processes or data sovereignty, those are good reasons to not move things to a public cloud. And some stuff just cannot move. We are working with customers who run legacy software and have been running it for a while. What do you do with that? And thirdly, and this is kind of when you move from sort of infrastructure, and in my background, a lot of networking, if you move towards the security space a little bit, although we are an infrastructure company, you realize very quickly that do-it-yourself security or do-it-yourself securing of enterprise data centers is inevitably going to fail. And I'm going to back these up with a bunch more points. But the reason that's interesting to note is that CIOs will over-rotate. They will say, others are being eaten alive right now from a security standpoint. I'm going to move everything that I can over to the cloud, even workloads that shouldn't be there. So this is what our belief is. What Skyport has built is to enable what's happening here. Embrace the fact that the cloud is essentially winning. Things are going to stay behind. Things are going to need to run close to users, going to have intellectual property that you cannot move. That's what the problem is that Skyport both feels passionate about and we've solved for from our perspective. So what is this not? I am not going to stand here and say that you should move to cloud. Absolutely not. Like, I couldn't care less. It's happening anyway. Other people have way better talk tracks about how you should move to cloud and whatever the reasons are for that. But that's not what this presentation and this day is about. It's also not about the exact opposite, which is you should move to cloud because it's other people's computers. Like, I don't really care. It's happening anyway. People are using it. They're happy with it. Life's so good. And what this certainly isn't about, and I want to make this really clear, is that we're not going to be here standing up here saying to you, you have to be more like Google, Facebook, Azure, any of the companies that have thousands of customers and hundreds of thousands of applications. Your disaggregated infrastructure is really nice to talk about, but that's not what this presentation is all about. So talk a little bit more about what we're seeing. Essentially, you're drowning in complexity. We are drowning in complexity. We're drowning in complexity of architectures. And it's one of the driving forces to move customers to move things off to the cloud for both good and bad reasons. But we're drowning in complexity of architectures. This is an example, very tiny example of an OpenStack architecture. It's great to fiddle with, and it's great to start building things with it. Really, if you have to support it, that's a whole different question. And whether or not it's OpenStack, Azure Stack, or even VMware, they've created tons and tons of architectures that are really complex to maintain and manage. The question is, does that really add to the overall end goal here? The other part of this is that you're fighting an unfair competition. You've heard a lot of people talk about this, but we have seen this firsthand with a lot of our customers. They are fighting an unfair competition. It's one customer, one data center, or a couple of data centers with a couple hundred applications against sort of big behemoths that have thousands of customers. Those are things you've all heard before. The thing that I would like to highlight here is amortizing the cost of running your infrastructure versus theirs is what the real trick is going to be. That's the real challenge. And amortizing the complexity is one that's even worse. And to add to the it's even worse, the expectations are going to be entirely the same. The expectations are, I can spin things up quickly in a data center, in a cloud. You have to do the same thing in a data center. If you are going to go with me on the fact that applications are not going to be held back and are going to move to cloud, then the following is going to make it even sort of exponentially worse, and that is the economics of any of the applications stay behind. Carrying that complexity is going to be really hard. So I mentioned before a little bit that adding to security or adding security knowledge to your abilities quickly turns you into somewhat of a pessimistic person. At least that's what my expectation is, or what my experience has been. One of the things that we have realized is there's no hope of creating a secure data center with the existing tools out there. And the reason I'm saying that is, very clearly, even people who have seemingly unlimited budget get owned left, right, and center. And that's scary. It's scary to the point that there are news articles out there that say, healthcare breaches this year, or so far, or the number of data records that are being lost. It's pretty much de rigueur. Everyone sees it every single day, and that's a problem. So that puts you personally, or us personally, in either of two camps. Running and being responsible for an infrastructure, either in the camp of, I'm armed, but vastly outnumbered, kind of painful to be in that position. We all know what happened afterwards, so you may be hoping for a miracle. Or the other side of this is, it's all fine. We're perfectly happy with what it is, and we'll wait until things happen to us. And that's a concern. We've looked at that and said that cannot be the case. You cannot, we cannot live with this. The other thing, and in our past lives, we've been sort of somewhat responsible for this as well. There's a vendor conflict of interest. The vendor conflict of interest is the following: that ever more complexity is pushed down your throat. And you and I and everyone else here is being trained to make their products work, to make them work together, to tweak them the right way, and even get certified in it. So you spend a lot of time in it. And don't get me wrong, I like tinkering with infrastructure as well. But if you think about it, should I be spending my time on that, or should I be spending time on using that infrastructure and building on top of that as opposed to underneath it? So that's a key challenge on one end. And the other, as a product manager, I'll carry this one myself as well. We got sold on software features. Like, we actively went into standards bodies and pitted vendor A to vendor B because our version of protocol something was better than that version of some other protocol. And that's, it's freaking painful. It's painful for you. It's painful for everyone. In fact, it's painful for vendors, but it's bringing in revenue. The complexity is paying off handsomely for them. To drive that point home, I did some research and essentially looked at where are you spending your time today? I'm not saying you personally, but where are the people who have to deal with infrastructures, where are they spending their time today? As it turns out, their to-do list is filled with hardening guides. We've gone in and looked at some of them, like hardening guides. Out of the 120 items for the top 2 items, the majority of it, 70% of it, is something you have to do after you unwrap the product. That's insane. It's like defaults should be set in the right way because the people who develop the code and who develop the product should know what the best way is to secure it. So the insanity from my perspective is that we live with this. We actually glom onto hardening guides. We're like, yes, we finally have a hardening guide. For some products, there isn't. I stopped short of going through all the OS hardening guides because that's even worse. And realistically, if you compare that to what happens in a cloud environment, when's the last time a cloud provider has asked you to upgrade in order to use a new feature? That disparity is unfair competition right there. It's complexity on one end, and on the other end, you're literally just consuming that infrastructure. So from our perspective, we think that the focus should absolutely be on, the focus of everyone should be on both the things that are on premises that are still going to remain there, because that's where you guys come in. And then that scope should also include things that run in the cloud and run in a cloud property. So with that in mind, we've looked at, is there a way to solve for this? And I mentioned earlier, Skyport stepped in and delivered after couple of years of hard development and now iterating with our customers and having a good number of customer successes out there. We believe that workloads have a choice. And in general, on the left-hand side, there is no argument for a workload to stay behind in a data center if complexity persists. Long-term, that's not tenable. It's impossible to do. And on the other end, and this, marketing hat on, Skyport, we bring what we believe is a very simple and very secure way, a much more secure way to run those things that cannot move to a cloud or that should not move to a cloud. Some of the properties of this would be, it has to be smaller. Those data centers don't balloon, they will actually shrink. They will shrink, they might distribute a little bit more, but they will shrink. The key point there, though, is complexity is engineered out. We're getting rid of all of the fancy acronyms that are being thrown around and the configuration languages that are of choice. The complexity has to leave. SDN is great, but in reality, nobody wants to re-architect your infrastructure. Nobody wants to go for a galactic reformation in order to bring this in. And the complexity of managing the infrastructure has to go radically down as well, because again, it's unfair competition. It's 3 of you against large organizations and optimizations on that front. So that's one part. The other is If complexity isn't going to go down, then security is clearly going to go down. So complexity goes up, security goes down massively. And on the other side, what we've architected for is a strict reduction of complexity by pre-integrating it on our side. We take on that burden of integrating it, and with that, we increase security. And in the rest of the talks today, we'll see how this is used and how this came to fruition. So then the question is, and I'm postulating a lot here, but as a company, it's our belief, and we're seeing this with customers, what goes where? What goes where is a big fat arrow from your existing workloads all the way to cloud. With, is there intellectual property involved, then maybe there's a reason not to move it yet. Well, you can sort of move it if the regulators don't object. There are workloads left, clearly, legacy, but to be true, if I look around the table here and in the audience, most of those workloads are either being identified as their legacy, we're not going to do anything with them anymore, we're going to stuff them in a pig pen somewhere, or we're going to re-architect them. And if they're re-architected natively for cloud. So basically what's left is things that are intellectual property, processes, data that needs to run somewhere close to where users are, and then these legacy applications that cannot move. All right, so fast forward. There is a maturity life cycle to this as well. So this is not all bad. As mentioned, data centers will exist. There's a ton of work for everyone around the table. But what we're seeing is workloads move out to that cloud infrastructure, whether or not it's for a line of business or for bulk compute. And some of it will return. But the way it will return is it will inherit an operational model that is true in those infrastructures today. Whether or not we like it, or whether or not it's the most efficient way, it is the way that's sort of a standard at that point. So the managed model won't look the same way, or quite the same way. And it's very likely that it will be more distributed than anywhere before. So closer to end users or closer to where your data sources are. So if you had this world where you had something simple, or simpler, so to speak, then what would it look like? And I guess you're all familiar with the sort of shared experiences model or shared responsibility model. And on the left-hand side, it's our version thereof. Everything in yellow is what we do for our customers, and everything in blue, which is the guest applications, the actual policy you set around those guest applications, and the data that runs on top of it, that's what you use. So most of the infrastructure is taken care of for you. Those details are taken care of. And what you build on top is where you can now focus your energy on. Or more concretely, you radically reduce the number of parts you have to deal with, the parts of the infrastructure you have to touch, either initially or on an ongoing basis. So from our perspective, and I firmly believe this based on the number of years I've worked on the vendor landscape, this stuff should just work. Like an API call over there, it just works in Azure and AWS and Google Cloud and all those other places. Why does that not seem to be the case in existing data centers today? From our perspective, it should just work and should free up the time to work on other more important things. So what does that next generation data center look like? It looks like this. The largest majority of that bulk compute is now ballooned up into the sky. There is a hybrid cloud edge, which is your anchor point for, it's anchored in reality in your data centers in an address that you guys own. That's the anchor point for identity management for these workloads that are legacy for these hybrid cloud environments. And you'll have a few of these hanging off the side, somewhere maybe in Singapore, somewhere in Europe, somewhere in the US, that have similar properties, similar protections, and run your services as such. So what should you do now? The three parts that we'll cover today: one, start with those critical systems. That's where most of our customers start. They look at their AD environment, look at how insecure that currently runs, move it over to a place where you can control it, observe it, lock it down. Hybrid cloud, enable this path to the cloud. Then we'll go through that in more detail. And then lastly, remote compute are essentially mini data centers, so we should treat them the same way.